Okay folks, let's raise the power in the room with quadratic graphs. Let's go! So we should first off say what a quadratic graph is. That's anything that involves an x squared. I think if you think like quadrilateral, squares of quadrilateral, there's probably some tenuous Latin link there. And there's two things that you need to be able to do. The first thing is we need to be able to draw them accurately. So that's what we're going to look at for a couple of slides here. And then we need to take the lessons that we've learned from that to be able to sketch them inaccurately, but still knowing, what sort of shapes they should have. So start with the very basic graph, y equals x squared. Now we're going to draw this, which means it's going to be accurate, and we're going to look at some different values of x for that to be the case. So we're going to substitute these in. I'm going to go all the way from -3 to 3. And then all we have to do, obviously, to get our y values is square that. Now, there's one big mistake people make here, which is that they'll write -9 here. Now, why is that wrong? Well, we are squaring -3. If you square -3, that means you are doing -3 times -3, and that'll give you 9. If you type into a calculator just -3 squared, what the calculator will think you want to do is do just 3 squared and then stick a minus on it. So it'll do -3 times 3, it'll give you -9. We don't want that. So if you are squaring negative numbers on a calculator, make sure you put a bracket around them if you want it to come up with the accurate result. Anyway, we'll get 9, 4, 1, 0, 1, 4, 9. You will spot some symmetry with these, and we're going to plot this as far as we can. So we'll just assume every square is worth 1 for now. So we'll have 0, 0, we'll have 1, 1, we'll have 2, 4, and I guess we'll have 3, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's up here somewhere. Then we'll do the same. We've got -1, 1, -2, 4, and -3, 9. Again, let's just assume it's up there. Joining them together shouldn't really be dot to dot. You can kind of get away with it being dot to dot in GCSE, but it should really be a smooth curve, and I like to draw each half of them separately. That'll do. So that's our general x squared shape, an upturned bowl or a parabola or something like that. Let's try and do the same thing with y equals -x squared. Now remember what I said about how important this is to put it in. If we want to do -3 squared, we've got to say minus and then -3 squared. That will give us -9. So let's see, we've got x and y, and again we're going to go from -3 to 3, and then the y values we should get then. So we said -3 squared will give us -9. We'll actually end up with all of these values being -4, being negative. Because we're squaring, which gives you a positive result, and then we're sticking a minus in front of it. Actually sketching this, so it's pretty similar to the points we had last time. How far down do I need to go off the page here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Down to here. And let's join them up together, and we get that. So what this gives us is the two basic quadratic shapes. Okay, when we've got y equals x squared, this is a positive quadratic. When we've got y equals -x squared, this is a negative quadratic. And the positive is a smiley face, and the negative is a frowny face, which is some wonderful symmetry. Okay, so let's increase the difficulty a little bit here. So here we've got y equals x squared plus 6x plus 8. So I'm not going to write out all of these calculations because it's going to take a little bit of time. For this one, by the way, we're going to go from -5 through to 0 for reasons that will become clear once we start drawing it. Okay, so let's just say I want to substitute in -5. Let's say I want to do that point. So according to this equation, I need to do -5 squared, so I'll put it in a bracket, plus 6 lots of -5 plus 8. So if you're typing it into your calculator, that's exactly how it has to look. If you're doing it in your head, you'd have to say, well, -5 squared is 25. 6 times -5 is -30, plus 8 is obviously plus 8, and that'll give you 33 minus 30. That'll give you a value of 3. So we'll be labeling this with x and y. And then if you go through the same process with the rest of them, if you put in -4, you'll get 16 minus 24 plus 8, you'll get 0. if you put in minus 3, you'll get 9 minus 18 plus 8 is minus 1. And then we'll get back to 0 again here. This will be 4 minus 12 plus 8. Back to 3. And then if 0 goes in, you get 8. Probably worth noting that whenever you put 0 in, you get the number that's at the end of the equation. It's the y-intercept. Anyway, so we can plot those points down. We've got minus 2, 0 as our sort of starting point. Minus 3, minus 1, minus 4, 0, minus 5, 3. And you kind of know what the shape's going to be like. This is obviously a positive quadratic. It's got a positive x squared. So we're going to get that upturned bowl situation. So 1, 2, 3, 4, 5, 6, 7. Slightly off the graph this time. Putting it all together, get that. And you do know that it's going to keep doing that because it's obviously going to be symmetrical. So yeah, there we go. Right, let's do one last graph here. X squared minus 3x minus 4. So for this one, we are going to go from minus 2. And we're going to go all the way up to let's go up to 5 and just see what happens. Okay. Now something you might want to start with 0, and I think that's always a sensible idea. We do know that this y-intercept is always going to be our 0 value. And then, again, if you don't like negatives, sometimes it's a case to work with the positives first. So you might want to do 1 as your first question and just do 1 squared minus 3 times 1 minus 4, which will give you 1 minus 3 minus 4, which will give you minus 6. Yeah. Okay, so if you put in 2, we're going to get ourselves to 4 minus 6 minus 4, which is going to give you minus 6 again, which is interesting, but we do expect some sort of symmetry, and we might expect then 3 to give us the value of minus 4, which it does. 4, if we put it in, we'll get 16 minus 12 minus 4, we'll get 0. And 5, we put it in, we'll get 25 minus 15 minus 4. So that is 6. And then you'll get the symmetry happening on the other side. So sometimes a way of drawing these is to work out 1/2 of the values to realize that there's symmetry and just apply it on the other side. You could, of course, check it if you wanted to check it. So let's take those points. Let's put them all together. This is going to be a positive x squared graph because of the x squared, so it's going to have that sort of shape going on. We have got, so minus 2, 6, 1, 2, 3, 4, 5, 6. We've got minus 1, 0. We've got 0, minus 4. We've got 1, minus 6. We've got 2, minus 6. We've got 3, minus 4. We've got 4, 0. And we've got 5, 6. So some good symmetry going on there. A mistake that people can sometimes make is to get to here and then just draw a flat line going across. That's not the case. We know this is going to curve down to some minimum point, so there should be a curve underneath those two. And then we'll join that all together, and that'll do. Positive x squared, so we've got the right shape, and there's our values. Okay, so let's reflect on what we have found out. Let's do that through the guise of an exam question. So we've got here x squared minus x minus 2. Quite often in the exam, they're not going to get you to fill in the entire table. They'll tell you to figure some out based on what they've drawn, and this is especially helpful if you want to work out our symmetry. We can tell that our symmetry is going to be here. That's like the minimum point is between 0 and 1. Nonetheless, we should put some values in. So for 2, we'd want to do 2 squared minus 2 minus 2, that is 0. For minus 1 squared, we're going to do 1 minus minus 1, so plus 1 minus 2, that's another 0. And we could probably expect this is going to be 4 because it was 4 over here. But we should check that. So 4 minus, so plus 2 because it's minus minus 2 minus 2. Yep, that is 4. Cool. So we've done part A. Part B, draw the graph. Now what shape are we expecting? Positive x squared, so we are expecting a upturned bowl shape or a smiley face. And it wants us to go from minus 2 to 3, so those are the only points we need to draw. Anyway, we've got minus 2, 4 as one of our points. We've got minus 1, 0. We've got 0, minus 2. We've got 1, minus 2. We've got 2, 0. And we've got 3, 4. And then we'll just join them up. Take your time with this. There's no point in rushing through it. do it point by point, and there we go, a lovely little positive quadratic. And then we got this third question. Write down the x-coordinate, so the x value, of the turning point of the graph. Now we haven't defined that yet. So a turning point is the minimum or the maximum point of a graph. It's the point where it stops going down and starts going up. And for our graph, based on our symmetry, we can clearly see that that turning point is here. TP, as we're going to call it. Now, what we've got to do is obviously write down the x-coordinate of that. We don't really know the y-coordinate because we might not necessarily draw on the graph accurately as far as how far it goes down. But the x-coordinate we can read off by just looking up to the x-axis. It's this point here, 0.5. Incidentally, sometimes they might rephrase that question and say, give the equation of the line of symmetry of the graph. And that would be the same thing because it's that dotted line that goes through 0.5 as well. Another way of getting that, and this is worth knowing, is to take the 2 points where we cross the x-axis. So we cross the x-axis at -1 and 2. What does that add up to? That adds up to -1. What do we get if we halve that? Sorry, that adds up to 1. What do we get if we halve that? 0.5. So another way of getting that turning point is to find the 2 points it crosses the x-axis and just halve it, because by symmetry it's got to be equal distances from both. Okie dokie. So that's drawing. Now let's look at sketching and a little checklist. So if you're sketching a quadratic, and to be honest this could be expanded to if you're sketching any graph, but in GCSE it's going to be a quadratic likely, there are 4 things you want to know. The first thing is the shape of the graph. We've already discussed this. If it's positive x squared, then we get a U shape, we get a smiley face. If we get a negative x squared, we get a frowny face. Second thing we'd want to know is where does this graph cross the x-axis, and the way we find where we cross the x-axis is to sub in y equals 0. I think this came up in the straight line graph stuff as well. Now, to solve it, we're going to need to use a technique, either factorizing or quadratic formula, but we'll come to that in the example. Thirdly, we want to know where it crosses the y-axis, and to get this we sub in x is 0, and we can also read it off from the end of the equation as well. And lastly, we want to know the turning point. Now this is an option. Sometimes if it just says sketch the graph, you don't need to write down the coordinates of the turning point, but it will often ask you to state it or go from there. I will point out there is another way of finding the turning point by completing the square. We are not addressing that in this video. We're looking at a nice cheap and cheesy way of doing it. So let's look at y equals x squared plus 12x plus 27. So let's go through the process. Shape-wise, this is a positive x squared, so it's going to have that shape. X-axis, sub in y equals 0. So here's our y. So we're going to say 0 equals x squared add 12x add 27. And we want to solve that. Now, I think the questions I've given you today are factorizable. So we're going to use factorizing to do it. And they're just x squared, so it's just x and x. And we need 2 numbers that multiply to 27 and that add to 12. And those numbers are 9 and 3. So we go through at 9 and 3, right? No, we need to solve it. So that means changing the sign at the very end. So we've got x is -3 and -9 as our 2 crossing points. Y-axis, sub in x equals 0. So that would be y equals 0 squared, add 12 lots of 0, add 27, which is just 27. You can also just read it off from the end of the equation now. So we've got 27 on the y-axis, we've got -9 and -3 on the x-axis, we've got our shape, and let's put all those things together and then we can work out the turning point. So sketch yourself a little axis, does not need to be accurate at all. And we want to say, firstly, let's do the points. So we want to go through the y-axis at 27. We want to go through the x-axis at 2 negative points at -9 and -3. Just make sure you've got them the right way around. And we know the shape that has to go through those is therefore going to be like that. And that is a sketch. Now, if you want to find the turning point, Remember what we said, it's the middle of the 2 points where we cross the x-axis. So to find the middle of two things, we add them up, so that adds up to minus 12, and divide it by 2. So that adds up to minus 6. So its minimum point would be at minus 6. You could have also just said what's in the middle of minus 9 and minus 3 and just thought about it, to be fair. What's the y value there? Well, if we want to get the y value, we need to substitute that x value into the equation. So we can say y is minus 6 squared, add 12 lots of minus 6 plus 27. Remember, brackets around anything that's negative. 36 minus 72 plus 27. So it's going to give you minus 9. So that coordinate is minus 6 minus 9. And that's it. That is our sketch. Shape, x-axis, y-axis, then turning point. Remember that checklist. It will see you through most of the graphs you ever need to do. So we're going to finish off by looking at 4 or 5 of these graphs. I'd like you to pause the video on each one to have a go, and then I'll talk through it. So first one we're going to look at is y is x squared minus 8x minus 20. Pause the video now, and I'll unpause in 3, 2, 1. So to start off, we should be going through the axis at 10 and minus 2, through the y-axis at minus 20, and that will give us the following sketch. And then the turning point is going to be halfway between 10 and minus 2, which should be at x equals 4. Sub that into the y equation and you'll get that the y coordinate is minus 36 for that turning point. Have a look at your coordinates and make sure they make sense. That turning point is below minus 20 because obviously minus 36 is less than minus 20. The coordinates in the right place, minus 2 is on the right side of the x-axis and so on. And yeah, it's a good sketch. Okay, a few more to go. So try this one. Unpause. Well, pause and unpause in 3, 2, 1. So there's the points that will cross the axis. Minus 5, minus 3, and 15. Generally what our graph will look like over there. And then the turning point is halfway between minus 5 and minus 3. So it's going to be at x equals minus 4. And the y coordinate will be minus 1. Cool. Let's try another. Pause the video. And I'll show the answers in 3, 2, 1. So there's a few classic things that catch people out here. Firstly, because we're used to equations that look like x squared plus 10x plus 9 or something like that, we'll start thinking of numbers that need to add to something and times to something. If your equation just says x squared add 10x, you can just take out a factor of x and just have it as like a simple bracket. That means we get x equals 0 from the x on its own and x equals minus 10 from the other one. And similarly, if we sub in x equals 0, we just get 0 out. So let's sketch it. There's not a huge amount of information to go on, but we do know it's a positive x squared graph, and we just got to go through those 2 points. Your turning point, obviously between minus 10 and 0, is minus 5. And then if we sub that into the equation, we'll get minus 5 squared, add 10 lots of minus 5, which will give you 25 minus 50, which is minus 25. So we've got minus 5, minus 25 as our turning point. All those equations make sense. Okay. 2 more to go. Here's your next one. And be careful, this is not positive. Okay? Pause. I'll show the answers in 3, 2, 1. So a couple of things to get you here. Firstly, obviously the negative x squared thing means our shape is going to be different this time. Secondly, this is a difference of 2 squares question. We don't have like a middle term. And if you think about it like add to something times to something, you're probably going to have a bad time. You've got to recognize this is square take away square. And the brackets are going to be just 8 plus x and 8 minus x to make that happen. So we'll cross at minus 8 and 8. Another way of actually solving this from here is we could have just taken the x squared across, said x squared equals 64, square rooted, and got that we go through at plus and minus 8. But, you know, factorizing still works. So if we mark those points down, we've got minus 8 and 8, and we go through the y-axis at, not down there, we go through the y-axis up here, 64, nearly made the mistake myself. It's a negative quadratic, so we're going to look something like that from there. And then what about the turning point? Well, we kind of already got it, because obviously halfway between -8 and 8 is just 0, and we already have that coordinate. So our turning point is just 0, 64. Cool. Okay, last question. Let's go. This is very much an extension activity, so if you can do everything up to this stage and you can't do this, you know, don't beat yourself up too much, but I think it's still worth considering. This is if you're aiming for anything higher than grade 7. So we've got a sketch here. It says if y equals x squared plus bx plus c, we can tell it's going to be positive from the x squared, but we also can tell it's positive from the fact that there's a graph drawn and it's positive. It says it goes through the x-axis at 5 and the y-axis at -10. And what we want to know is the x-coordinate of the turning point of the graph. Now, how are we going to do this? Feel free to pause at this stage and have a go, but I'm going to just talk through it if you don't do that. So obviously we know the turning point is exactly halfway between P and 5. And so we kind of need to work out what P is. So let's think about our equation. Our equation is y equals x squared plus bx plus c. And we know that it will factorize to something involving x. Now, what else do we know? We know it goes through at 5, so that means one of the brackets must be x minus 5. What else do we know? Well, we know it goes through the y-axis at -10, so that means this plus c at the end must be -10. Why is that? Well, because that's the only bit left over when we sub in x equals 0. Okay, what else? Well, we know that these two numbers in the bracket have to multiply to give us -10. So -5 times something equals -10. That's +2, isn't it? Okay. So we need to still figure out anything, do we? Not really. We could figure out b at this stage, but at this point we actually have our value of p, don't we? Because we know our solutions are x equals 5, which we've got, and x equals -2, which we don't. So we can say that this is not p, this is -2. And if we want to find the turning point of the graph, we need to find the middle of those two things. So we would go -2, add 5 is 3, and then divide by 2 gives you 1.5. So this turning point here is 1.5 something, and we're done. However, in the interests of completion, I would point out that it is possible to work out what b is as well. Because you could think about this factorizing. Remember, we needed two numbers that times to -10, which they do, and they add to this number in the middle, they add to b. What is -5 add to? That's -3. So we could change this, therefore, to our final equation of x squared minus 3x minus 10. And if we wanted to figure out what the turning point actually was, we could sub 1.5 into it. So we could go, okay, give me 1.5 squared minus 3 lots at 1.5 minus 10. So that's 2.25 minus 4.5 minus 10, which is minus 12.25. So if you wanted to go even above and beyond and answer more than the question in front of you, you could. But yeah, the key point there was realizing how factorizing works. Okay, that's quadratic graphs. Look forward to the next thing, which I think is going to be cubics. We're raising the power once more.